Oh. All right. Thank you.
Okay. Okay, so hi everybody, I'm Alessandro, as you know, and today I'm going to cover a little part of chapter 7, which is talk about design processes. So I will continue the part that explained Professor Han. Okay, so I'm going to focus on chapter 7.2 and 7.3. 7.2 is about control by regulating design actions, and chapter 7.3 about planning design actions. And so here we can see more in details the topics. So for the first part, I'm going to explain what is the Blackboard control model, and then how can you apply the Blackboard control model to producing designs. And then for the planning design actions, there are two types, which are forward chaining and backward chaining, and I'm going to explain more in details how do they work. So first of all, I want to do a little recap in order to understand better what I'm going to explain later. So chapter 7 is about design processes, and so when we're talking about design process, we talk about actions that are required in order to execute a certain process. And as Professor explained before, these actions can imply some issues, and these issues can be regulated in planning or abstraction levels, and conflicts and decompositions. So in order to overcome these issues, we have to focus on two aspects of design actions, which are control and planning. So basically, these two aspects are going to be analyzed more in details in the two chapters. In 7.2, we are going to explain about the control of the processes, and this is achieved by regulating the design actions. And in the chapter 7.3, the focus is more on the planning part of the design actions. So, okay. If we want to control design actions, we need a system that can handle basically four main areas, and these areas are listed here. So we have to handle the combinatorial problem, multiple search strategies, and non-uniform knowledge representation, and contradictory and conflicting knowledge. All this can be done using a Blackboard control model. So let's see what is this Blackboard control model. The Blackboard control model is presented with three major parts that you can see in the graph on the right. And this model is made of knowledge sources, partition, fact base, and control, which basically control all the model itself. So let's see more in details these three parts. So the knowledge sources are like distinct and independent units, and each unit solves a partial problem, and after solving this partial problem, we can interact all these solutions through the Blackboard, through all the entire model. The partition fact base, so basically the facts are organized in partition in hierarchy. So as you can see in the figure, we have different levels. In this case, there's an example of designing a living room. So you start from the bottom level, level 0, and after you design, you see like the line, the rectangle, which represent the area of the living room, and then you know the position, so north, south, east, west, and all the components inside the living room, how are they placed each element compared to the other one. And in this way, like going always more in details, you reach your goal and design your living room. So yeah, basically the knowledge sources make changes to the Blackboard, and incrementally you arrive until the solution of your problem. And finally is the control, which basically managed to task and check the work state. So it's like the fulcrum of all the Blackboard model. And what it does is to check every knowledge, every action we have, and see if it matches the description of the goal. And you evaluate in an heuristic way. So basically you making trials and see if this every action can solve the problem. And you make a hierarchy of all the actions, and you when you have this hierarchical order, you execute the action in order from the highest priority to the bottom priority. So this Blackboard model can be used as an approach to producing designs. And one example is shown here in this figure. This example is a site plan, which is a software who generates construction site layouts. So as you can see, basically it arranges all the cranes that we need for make a construction, and see what's the area in which we have to work, the dimension. And this is a typical example of how you use this approach. And as I explained a little bit before, this model needs to be done with an execution cycle. And so basically you execute all the, you have all this, your knowledge and your actions, and you make as I explained before, like a hierarchical list, and you execute the events according to priorities, and this way you are able to execute all the passages you need until arriving to the goal. So until now I talked about the control, and now I'm going to focus on the planning of design actions. So when we talk about the planning of design action, we have to know that there are two types of plannings. The first one is forward chaining, and the second one is the backward chaining. The forward chaining consists of selecting and ordering the actions that we have to implement. So basically, as you can see in the figure, if you want to, we start from point A, and our goal is to reach point B. What we do is to plan the entire path. So basically, we're going to say we want to arrive here, so we have to go here, 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 and when we plan all the points, we make all the path until the goal. The backward chaining basically is the opposite of the forward chaining. So instead of starting from the origin to the goal, we start from the goal and we plan backwards all the path we need to do. The problem of this backward chaining is that if we have multiple goals, and when one goal it basically negates another one, we can have problem of implementing this type of chaining. And one example of backward chaining is the GPS, which is a general problem solver. And the GPS works basically it calculates the difference between the current work state, so on the point we are right now, and the final goal, and it tries to find to reduce the difference between the current state and the final goal. So when we reduce, we have a different current state, we reduce until basically the current state and the goal are the same. In this way we reach the final goal backwards. So here we can see, to conclude more in detail, is the backward chaining in the figure. So what you do is start from the from the top. You see the top chart over there. This is the goal. And in order to understand how to reach it, you go back and you analyze an action which can lead to the goal. And if this is like the sub goal, if this action doesn't reach the goal, so like the one on the right, which is written fail, if it doesn't, it means that you have to find another one. So you go back, you try to find another one, and when you find the correct one, you just basically go back until you arrive to the origin. So yeah, these are the backward chaining. And yeah, I conclude my presentation. Is there any question or comments? Okay, thank you.
Continue on this question. You are ready. All right, then we can finish earlier. Okay, we'll see you on next Monday.
Can I take it off? Or,
Maybe.
yeah. Okay. I'm gonna put in the discussion Google Drive, the file.
Or email.
Okay.